Hello. The purpose of this video is to try and give you an introduction to the sulfuric acid synthesis lab experiment that we're going to do so that you'll be able to fill out the pre-lab assignment first of all, and then just have a general idea of what's going to happen when we get to class on the day that we do the experiment, or at least the day that we start the experiment. So this is the cover page of the handout you received. And then this is the pre-lab assignment that I gave you. And I'm just going to say right now, I have made a couple changes to this pre-lab assignment from what I handed out. Just a couple brief changes of language in a couple of these questions. So when you actually go to fill out the pre-lab assignment, you might want to download the one that's in Veracross instead of the hard copy I handed you because it is phrased slightly differently. Or you could fill out the hard copy that I gave you, but download the one online just to read through. Anyway, so what are we going to do? We are going to make sulfuric acid. But unlike, say, some other reactions we've done, like the zinc and iodine reaction, where it was very simple. We put zinc and iodine together and it made zinc iodide. There are actually going to be a lot of different reactions going on in the pot when we do the sulfuric acid experiment. So let me just walk you through these. So I got to get all the way back to the beginning. End of this. Okay. So what we're going to do is we're going to put some sulfur and some sodium nitrate into a little container that gets suspended inside of a soda bottle with a little bit of water in the bottom. We're going to use the blowtorch to light the sulfur and the sodium nitrate on fire, and then we're going to put that into the bottle with the water and watch it burn. And when on the back end, you get out sulfuric acid, but that's actually the culmination of four steps in the process. The first step is the sulfur and the sodium nitrate in the little cup are going to react to produce sulfur dioxide, sodium sulfide, and nitrogen monoxide. Now you notice that none of those things is sulfuric acid. The sulfur dioxide is what's going to eventually become sulfuric acid, but it's not there yet. The next thing that's going to happen is that nitrogen monoxide that we produce is going to react with oxygen inside the bottle, from the air inside the bottle, to form nitrogen dioxide. Then the nitrogen dioxide that we produce is going to react with the sulfur dioxide. Remember I said that the sulfur dioxide was what is eventually going to become the sulfuric acid. That nitrogen dioxide that was produced by the reaction of nitrogen monoxide with oxygen is going to react with the sulfur dioxide to produce sulfur trioxide. And meanwhile, the nitrogen dioxide is going to be turned back into nitrogen monoxide. This is almost like a tongue twister. And then the sulfur trioxide that we made in that third step is going to react with the water in the bottom of the bottle to produce sulfuric acid. So SO3 plus H2O gives H2SO4. Okay, now you have let me just go back and show you again the handout that you're supposed to do. This asks you to write out the equation. So I'm elemental sulfur plus sodium nitrate gives you sodium sulfide plus sulfur dioxide plus nitrogen monoxide. I'm expecting you to be able to use your nomenclature skills to write out a reaction given those names, and then to balance it. Then to write out the reaction, nitrogen monoxide reacts with oxygen. Remember, oxygen is part of Hofbrinkel, so it's got to be O2 to form nitrogen dioxide, and then balance that. And then nitrogen dioxide reacts with sulfur dioxide to form nitrogen monoxide and sulfur trioxide, and to balance that if necessary. Now, what part D asks you to do is to sum up reactions B and C so that the NO and the NO2 cancel out. Those of you who were with me last year will remember that we did something similar to this when we were talking about what's called Hess's law, trying to get reactions to add together to give us a particular reaction and to cancel out things we don't need. The thing is that if you try to just add B and C together directly, they're not going to cancel. So let me just go back through and give you an example of what this is. Not the same reaction. This is a different series of reactions. But this will be illustrative of what it is that you actually have to do on the handout. Suppose you were given these three reactions. C2H4, ethylene, decomposes to carbon plus H2. Carbon plus F2 gives you CF4. Hydrogen plus fluorine gives you hydrogen fluoride. And you are asked to do two things. First, you have to balance the equations, and then you have to add them up so that the C and the H2 cancel out in the summed equation. Now, on the face of it, that looks pretty easy because I've got one C on the left and one C on the right. I've got one H2 on the left and one H2 on the right. So I ought to be able to just add these up right now and have them cancel out. The problem being that I haven't balanced them yet. So let's balance the first equation first. In order to balance the first equation, I need to add a 2 as a coefficient of the C, and I need to add a 2 as a coefficient of the H2. So that's balanced. In order to balance the second one, the carbon's already balanced, but I need a coefficient of 2 in front of my F2, so I can have CF4. The third one, in order to balance it, I need to put a 2 in front of the HF. Now I've balanced all these, but in the process of doing that, you'll notice I have put them out of whack for getting them to cancel each other, because now where I have one C on the left, I have two C's on the right. And where I have one H2 on the left, I have two H2s on the right. So in order to balance these, in order to add these up to get the carbon and the hydrogen to cancel, I'm going to need to multiply this equation by 2, right? So I'm just multiplying all the way through by 2. Instead of 1, 2, 1, now it's going to be 2, 4, 2. And to get the hydrogens to cancel, I need to multiply this one through by 2. So instead of being 1, 1, 2, it's now going to be 2, 2, 4. Now when I add those up, carbon cancels carbon, hydrogen cancels hydrogen. I get C2H4 plus 6F2 gives C2CF4 plus 4HF. And if you go through and look at this, you will see that that is a balanced equation and everything cancels out. So that's giving you some guidance as to what you're going to need to do on the pre-lab handout sheet. There are a couple times in there where I say add this reaction to that reaction such that X and Y cancel out. And in each case, you're going to have to do some kind of a manipulation to one of the equations, either multiply it by a particular factor or divide it by a particular factor in order to get it to cancel, to get things to cancel out. And I'll just tell you, it's going to be multiplying by a particular factor. Okay, let's switch over and talk about, so there are three parts to this. There are three parts to the experiment we're going to do. One of them is making sulfuric acid. Another part of it is trying to figure out how much we made. And another part of it we have to do before we can figure out how much we made. So let me back up and say, we're going to make sulfuric acid. How are we going to figure out how much of it we've made? Well, with a lot of chemical reactions, and this is particularly true when you do organic chemistry, it's generally what you do is you isolate your product and you determine its mass. A lot of organic molecules are crystalline, so you can crystallize them or recrystallize them. And then you can simply weigh your product to see what you got. Sometimes an organic reaction gives you a liquid product, and then you could say maybe distill that liquid and then isolate it and then weigh it and see how much you got. Sometimes you have to do what's called column chromatography, which is not something I'm going to talk about in detail, but this is a way of separating things, say, that are mutually soluble, so there's no real easy way to get them apart. And once you've isolated your product that way, then you can weigh it and figure out how much you've got. You cannot do that with sulfuric acid. Unless you own, is what I've said here, unless you own a sulfuric acid factory, it's essentially impossible to isolate pure sulfuric acid from a reaction. So we're going to make sulfuric acid. It's going to be dissolved in water. There's going to be other stuff in there too. We can't distill it off. because the water will distill off first. And what that gives you is concentrated sulfuric acid. And you can never get concentrated sulfuric acid completely pure. The stuff that I buy from the suppliers is 96% sulfuric acid and 4% water. But there are going to be other things in there too, ionic compounds and stuff. Plus, highly concentrated sulfuric acid is really, really dangerous. So we're not going to do that. Instead, what we're going to do is we are going to do what's called a titration. You're going to take the sulfuric acid you made and you are going to react it with sodium hydroxide in an acid-base reaction to give you sodium sulfate plus water. The way a titration works is you put in what's called an acid-base indicator that will change colors right when this reaction is done. So just when you've added enough sodium hydroxide to completely neutralize your sulfuric acid, the titration reaction changes colors, and then you know to stop. And if you know the concentration of your sodium hydroxide, and you know what volume of sodium hydroxide you used to neutralize your sulfuric acid, you can then calculate how many moles of sulfuric acid you used, and then you can use the balanced equation to figure out how many moles of sodium hydroxide you used, and then you can use the balanced equation to figure out how many moles of sulfuric acid were in there, and you use that to calculate your yield. This is what's called, so we're combining a couple things yet here that we haven't actually learned about yet: solution stoichiometry and acid-base titration. But we will learn about solution stoichiometry later in this unit. So that sounds good, but there's one more problem, and that is it's really difficult to make a solution of sodium hydroxide of known concentration. So I've said here, this works if you know the concentration of your sodium hydroxide. It's really hard to make a sodium hydroxide solution of known concentration. And so what you have to do is make a solution of sodium hydroxide and then try and figure out what its concentration is. And to do that, we're going to use a process known as standardization, in which we're going to use a known quantity of another acid to react with the sodium hydroxide to figure out its concentration. It's a process similar to calibrating a balance. So here's a picture of somebody calibrating a balance. A balance is no good, right? If it can be really precise, but if it's constantly telling you the wrong mass of things, that's not a very good balance. And so you can get, and we have actually in our classroom, a calibration kit of various objects of known fixed mass, and you use that, and there's a calibration program on any balance, and you can use these masses in the calibration program to calibrate the balance and so that it is measuring masses correctly. That's basically sort of the philosophical underpinning of what we're doing in this experiment. So what we're going to do is the first thing we're going to do when we get in there is we're going to do a titration to standardize the sodium hydroxide solution. Then we're going to make the sulfuric acid. Then we're going to use our standardized sodium hydroxide solution to titrate the sulfuric acid and figure out how much sulfuric acid we've made. Okay, so that's the end of this video, but you'll want to look kind of carefully through the assignment in Veracross, because there are three things really it's going to ask you to do. It's going to ask you to watch this video, which you've now done. Then you are going to complete the handout, the pre-lab handout that I gave you, which involves balancing equations, adding equations together to get the final equation. And remember, you'll want to go on to Veracross and get the most updated version of that handout. And then the last question asks you to do a limiting reactant calculation to figure out what the theoretical yield of sulfuric acid is that you're expecting. It says if you mix half a gram of sulfur, if you burn half a gram of sulfur with 1 gram of sodium nitrate, which of those two is the limiting reactant, and what is your theoretical yield? Most of you will be familiar in the past with limiting reactant problems. Let me just remind you how this works. What you do is you take each reactant, So you take the half a gram of sulfur and doing a roadmap 2 stoichiometry calculation, you figure out how much sulfuric acid you could make from half a gram of sulfur. Then you take your 1 gram of sodium nitrate and doing a roadmap 2 stoichiometry calculation, you figure out what mass of sulfuric acid you can make from your 1 gram of sodium nitrate. Then you look and see which of those two theoretical yields is smaller. That's the actual theoretical yield, and the reactant that gave you that smaller yield is the limiting reactant. You're going to watch this video, what you've done. You're going to do the pre-lab handout, and then I will also in the assignment have posted links to some external videos on just familiarizing you with how an acid-base titration works, so that when you come into the lab to do the experiment, you won't be totally in the dark about what you're going to do on the acid-base titration. So once again, take a close look at the assignment in Veracross. Make sure you're doing everything it asks you to do there. And thanks for watching.